Hi everyone. We are currently reviewing some materials, some chapters from grade 9, which are very important to the completion of the upcoming chapters for grade 10. We should know that we have a Pythagoras theorem, the most essential theorem for right angle triangle. So we are dedicating this session for the right angle trigonometry theorems and properties and everything about the features of in these type of triangles. Okay. So normally, the first essential theorem is Pythagoras theorem. We should know that the hypotenuse, which is the side opposite to the 90 degree, hypotenuse square equal to the sum of the square of the rest of sides. Okay. So normally, we should know that the hypotenuse is the longest side in a right triangle, or we can say it is the opposite side to the right angle in a right angle triangle. The Pythagorean theorem can be written as three different expressions, like hypotenuse square equal to the first the sum of the other sides squared, but or we can say that one side squared equal to the hypotenuse square minus the other side squared, or the other one equal to squared equal to the hypotenuse squared minus the remaining one squared. Okay, so we should stress on the fact that this theorem is authorized to use only in a right triangle. Okay, so we should know if this expression is verified. We know I mean, if hypotenuse square, if we verify the values given for any triangle, if these values verify this expression, hypotenuse square equal to the sum of the squared of the other side, so normally the triangle is a right triangle, and if not, that triangle is not a right angled. Okay. We should know that in a right angle triangle, we have different way of thinking, and the most standard thought about naming sides are if we have three angles, we should know that in fact in any triangle we have three angles, three sides. Okay, but specifically in the right angle triangle, we have a 90 degree and we have two other complementary angles. What we mean by complementary angles? We mean that the sum of the remaining angles equal to 90 degree, because we should know and we should keep in mind that the sum of the angles in the same triangle equal to 180 degree. Okay, so if we have a 90, so the sum of alpha, phi, and theta equal to 90 also. And we should know that if we are talking about theta, so the opposite side to this angle, we can denote it as opposite. And the other side, which is not the hypotenuse, we should know that the hypotenuse is always the side opposite to the 90 degree. We have a 90 degree here, so the opposite to that, we can, for example, draw a ray coming from, starting from B, straight away to AC. So normally AC is the opposite side to 90 degrees. So we can call it the hypotenuse. Okay, so the other side is the adjacent for theta, and phi. For phi, for example, the opposite is AB. Since AC is the hypotenuse, always remain as a hypotenuse, known as hypotenuse. So BC is the adjacent for phi, and so on. Okay, so we should know that we should know that we have three different the most known important trigonometric ratios are tangent theta, sine theta, and cosine theta, involving the adjacent, opposite, and hypotenuse sides of each given right angle triangle. So, for example, we have here theta. We have, first of all, we have a right angle triangle. We have an angle. So, with respect to this angle, the opposite is BC. The hypotenuse is always the opposite side to the 90, so it is AC. And the adjacent is the remaining side, so it is the next, right next to this angle, other knowing the hypotenuse, okay, another one or different from the hypotenuse, okay. So we should know that the sine is always opposite over hypotenuse. Sine theta is opposite, so it is a BC over hypotenuse is the over AC. Cosine is the adjacent, so AB over AC. And the tangent is always known as the quotient of sine over cosine, or is known as the opposite over adjacent, so opposite over adjacent. So it involves BC over AB only. For example, here, they ask us to write the expression for sine alpha, cosine alpha, tangent alpha, sine beta, cosine beta, and tangent beta. So we have here alpha. So normally the sine is the opposite, so Q over hypotenuse over P. Cosine theta is the adjacent, R over hypotenuse is P. So and tangent is the opposite, Q over adjacent over R. When talking about cosine beta, so normally sine beta is opposite. The opposite is R over P, and we know that R over P is equal to cosine alpha. So normally we can remark clearly that sine beta equal to cosine alpha because beta and alpha are complementary angles. So we should know that if we have two angles complementary to each other, so complementary, we may mean that beta plus alpha equal to 90 degrees. So normally the sine equal to the cosine of the other one. Okay, and you can complete the other examples by yourself, easy. Also, we can use trigonometric ratio to find angles. Not only we can search sides using trigonometric ratios, but also we can find angles using the inverse sine, inverse tangent, and inverse cosine, using shift before any of these bottom. Okay, so let's continue the following. For example, we can use trigonometry to find sides, to find angles also. So using sine ratio to find the opposite side, while the hypotenuse and the angle are known. So normally we should know which sides are involved and which angle is known to know which one we can use. So normally here, if we have the hypotenuse, we have a sine theta, and we want to find opposite. So normally we are involving in the same expression, the opposite and the hypotenuse. We have the opposite over hypotenuse equal to sine. So we use the sine ratio. In this way, the opposite is equal to sine by hypotenuse, and so on. For example, in the same way, if we have the adjacent and we want to find the hypotenuse of a given, and we have a theta as angle. So normally adjacent hypotenuse involving these two sides. So normally we need we need to use the cosine ratio. So in this way, we have the hypotenuse equal to adjacent over cosine, and so on. So normally we should know what we have and what we need to find. Okay, in the same way we can explain that using of tangent sides, a tangent ratio, and the situation suitable for using it. For example, I want to discuss a little bit about finding the length of the side marked X. We have a X. we have a 34 degrees. So we know this angle, the measure of this angle. When we know the measure of this angle, so normally we want to base our study on this angle, on the measure of this angle. So for this angle, we have the opposite, we have the adjacent, which is x, and we have the, the adjacent, which is 10 centimeter, and we have the hypotenuse x. So we need to find the hypotenuse while we have the adjacent side, and we have the measure of this angle. So which expression or ratio, trigonometric ratio, involve adjacent and hypotenuse is the cosine. So cosine 34 degree equal to 10 over x, equal to the adjacent over the hypotenuse. Normally, we want to find x, so x equal to 10 over cosine 34 degree. And after after approximation to the third significant figures, so the first significant figure, the second one, and the third one. So we investigate or we compare the next locate the next number digit located to its right, which is 6. 6 is greater than 5. So normally we approximate or we add 1. Okay, we round it up. So we add 1 to the third significant figure. And you can also use, for example, we can discuss the third one. So we have a 57 degree at the measure of the angle, normally 10 meter. 10 meter is the opposite side. We have the opposite, we have the adjacent. The hypotenuse is unknown. And the adjacent, we want to find the adjacent and opposite. So normally the ratio that we can use, are recommended to use is the tangent ratio. Okay, and so on. So please try by yourself this plan, and you will succeed definitely. Okay. Also, we can use trigonometry to find angles. So easy, also easy. So we should we want to investigate first, or to discuss which side we have and which angle, to choose the suitable trigonometry ratio to find the unknown angle that we want or interested in. For example, they ask us to find the value of theta to the nearest minute. Okay, so we have a theta. With respect to theta, 4 centimeter is the opposite, and 7 is adjacent. So normally, adjacent opposite side. So normally we use the tangent theta. So using tangent theta equal to the adjacent, opposite over adjacent. So how to find theta? So by the inverse tangent. Theta is the inverse tangent of 4 over 7, which gives us, using the calculator, 29.7448 degrees. But they ask us to find the correct answer, the correct value of theta to the nearest minute. Using the bottom, the right bottom to convert for a minute and seconds, so we obtain 29 degree, 44 minutes and 41.57 seconds. We want to round it to the nearest minute, so we want this part to cancel this part, but when canceling this part, we compare it to 60 or to 30. If this part is greater than 30 or equal to 30, so we round the minutes up. So normally 41 is greater than 30, so we round it up to obtain 45 minutes. And the following problems are also easy. The essential and the important idea that that I want to stress on is about, for example, they gave us here a right angle triangle. And they ask us to find all the sides and angles in that given triangle. We should know that any triangle contains 3 sides, or consists of 3 sides and the 3 angles. Okay, here, for example, we have a 90 degree. This mark represents the 90 degree. 51 degrees, and we should know that the sum of all angles in the same triangle equal to 180. So normally theta is the remaining value from 180. 180, we subtract from 180 the 51, or the sum of 51 and 90, or we subtract 51 and 91 from 180 to obtain theta. So normally theta is 39 degrees. In this way, we have the three measures of the three angles here. Okay. Next, we want to find x. According to, or with respect to 51 degree, x is an adjacent and 28 is a hypotenuse, so adjacent hypotenuse, so cosine ratio. Okay, and we obtain the value in meter. Next, if we want to find y, normally in any right angle triangle, if we have the measure of the values of each one of the two other sides, so normally we can use the Pythagorean theorem. Okay, it's easy way. So normally in this way, y squared equal to 28 hypotenuse squared minus x squared. But also we can use any trigonometry ratio, the suitable one. Okay, so normally we have a theta, or we have normally 51, y is the opposite to it. For example, we have several methods. So y is the opposite to 51, and we have a 28 as hypotenuse, opposite hypotenuse, we can use sine ratio. Or according to theta, y is the adjacent, and 28 is the hypotenuse. So normally we can use also cosine. So you are free to use any convenient method to find the 21.76 meter as length for y. For the last part in this question, we have a boat, and we wanted to find the elevation length, or we want to find the height of the cliff above the boat. So normally we want to find this part. Okay, so we want to find this part, and this part is so normally this part is represent the opposite to 7 degree. And so we have an opposite, we have an adjacent. We don't have the hypotenuse value, length of the hypotenuse. So normally adjacent and adjacent and opposite. So normally we use the tangent ratio to find the height of the cliff. So these are important ideas about the right angle triangle, all about Pythagoras theorem, trigonometry ratios, and how to use these trigonometry ratios to find sides and angles in any right angle triangle. Thank you for listening. Bye bye.